All right, so let's see here. We left off, we're talking about METARs and PIREPs. So we got through PIREPs. So now I guess we can start discussing aviation forecasts. So let's look at the first type of forecast, which is going to be what we call a TAF. TAF stands for Terminal Area Forecast. Basically, it just means it's centered on some airport. These read a lot like METARs, so as long as you can read a METAR, it's likely you'll be able to read these as well. So let's pull up a current METAR from Houghton. This is what they look like. Looks a lot like a METAR, reads a lot like a METAR, except this contains forecast information. In fact, if I pull up a METAR, you can see this is the METAR and this is the TAF. We're only gonna look at the METAR, so I'll pull it that way. So it starts out with the identifier. It gives you this is the date and time that the TAF was published. So this was the 19th of October at 17:30 Zulu. Then you get some other information here, which is the forecast valid period. So, so it's valid the 19th of October at 18:00 Zulu to the 20th of October at 18:00 Zulu. And then from there, you can get a little bit more information about the general forecast. So forecast predictions for this time period. This is just kind of an overview. It's not like a hard set rule for the forecast. The more detailed forecast comes below this line. But this top line is kind of like a just general overview. So winds are going to be 250 at 7 knots. Visibility. Now, this is a little bit different than in the METAR, but they put a P in front of the 6 because in the TAF, they report maximum visibility at 6 statute miles. They don't predict anything greater than that. And so when the visibility is predicted to be greater than 6 statute miles, what they do is they put a P in front of it, and the P just means that visibility is predicted to be greater than 6 statute miles. If it's less than that, then it'll just say whatever that visibility is predicted to be. The next thing here is going to be the precipitation type, if any. In this case, it looks like vicinity showers. It doesn't say what kind of showers, so we'll just assume it's some type rain, snow, something. So VC for vicinity, and then SH for showers. Then it gives you some basic cloud information. So it looks like clouds for this forecast period are going to be broken at 4,000. Then below that main line of the TAF, which is here, you're going to get more detailed forecast information for specific times during the forecast period. And each line indentation will begin with FM, which stands for from, and then it'll give you date and time. So this is going to be from the 20th of October, starting at 06 Zulu. So, or 600 Zulu, which if you did some math, you could figure out what that is in Eastern, but currently the time is 23. That's not quite right. 25 UTC. So, or no, 23:05 UTC is the current time. And so you could figure out this is only about 7 hours into the future. So this is from the 20th of October at 600 Zulu, which is about 7 hours from now. The wind is going to be variable at 4 knots. So this VRB means variable. Basically, it just means that they don't assign it a direction, and at 4 knots. So when you see this variable, basically all that means is either they're not going to be able to predict the wind direction, or the wind is just going to be so low it's not going to matter. So in this case, it looks to be the latter. So 4 knots is very low wind speeds, and really the wind direction probably is going to be hard to predict, or it doesn't really matter in that case. So, and then again, you see the visibility here. So greater than 6 statute miles, and then they give you the cloud layer. So broken at 4,000 feet. I'm going to pull up another TAF because this one's not very detailed. It only has one line. Yes. So this is a TAF for Grand Rapids. Looks like the one from Houghton, except it has a few more lines. So we get a little bit more forecast information. So the top line here, this is for Grand Rapids, date, time. This is the forecast valid period. And then you get wind, visibility, and then you get clouds. So in this forecast, we have 3 lines. Now, this is kind of where reading TAFs get a little bit tricky. So when you see from 19, that's October 19th at 2200 Zulu, what this means is this forecast line is valid from 2200 Zulu until the next line. So the next line is the 20th at 000 Zulu, or 8 o'clock Eastern time right now. So this forecast goes from this line until the next one, and then this one goes until the next one, and then presumably the last one will go until the end of the forecast period. So that's kind of how you read these different lines and the forecast valid times. So there's not much different. I just wanted to point out that how these from times work on these TAFs. So reading the lines is all the same. Mexican. So any questions on how you read a TAF versus a METAR? All right. So let us pull up another forecast tool. This one is called a area forecast. Now they have changed area forecasts around, so they're not what they used to be. They're actually a lot better than they used to be. So when you go to the area forecast page on aviationweather.gov, it'll bring you this page, which says that the area forecast tool has been deprecated or whatever, and you now get this. This is the graphical forecast tool, and basically it puts everything out on graphical layout instead of the old way, which was much worse and was not necessarily graphical. So there's a lot of information that you can get from this, and I find it's really helpful for getting a nice overview of what weather's doing around the country and what it might do around your area. It has a lot of tools embedded into it, so it's very useful. So if we want to take a look at Houghton's area up here, the first thing we can do is we can go up here and we can select TAF, and then we can get all the TAFs for the airports. So this, when you click on an airport, will give you the TAF for that airport, and you can read it. And so that's kind of nice. You can also get overlays. So you can get like forecast overlays. These are like obscurations, warnings. Then you can get all kinds of other different warnings and overlays and all kinds of stuff. So you can choose what you see on this page. But we'll stick with forecast. So forecast tool will give you TAFs. It'll give you ceilings and visibility. So this is the forecasted ceiling and visibility. If there's this little legend down here that tells you how to decode this, but if there's nothing, that means it's VFR. Specifically, it's greater than 5 mile visibility, because MVFR, like we talked about a few weeks ago, is 3 to 5 mile visibility. IFR is classified as 1 to 3 mile visibility. Then low IFR is anything below 1 mile. So looks like across the country here, they're going to have some low visibility. Up here, there's a little bit of lower visibility, but up here, we're okay for the forecast period. The other thing I should mention before we move on too far is that you can slide this out and it'll give you forecasted visibilities at intervals. So this is at 4 Zulu, and you can kind of see how they move along. It'll tell you this is plus 8 hours. And so it'll go out all the way to 17 Zulu, which is plus 18 hours. So that's kind of nice. So you can kind of see how things will change over time. You can do that for all these different things. So if you want to see how cloud coverage would change over time, you just use this little slider and you'll see what the cloud coverage is predicted to be at a certain time in the future. So that's kind of nice. And again, you can see the legend down here and how those are broken up. You can see precipitation forecast. So for here, it looks like we're predicted for snow, which may or may not be a good thing. We'll find out. Sometimes it takes a few seconds to load. There also are represented symbolically on the map. So if you, for some reason, had this like printed in black and white or the colors weren't available, you can also read these symbols, which have different meanings. So like this little triangle with a dot is rain, dots are rain, dot with a snowflake is like a rain snow mixture or sleet. Commas are like heavier rain or sometimes associated near thunderstorms. You know, the more things there are, usually the heavier it is. So you can see right here is heavy snow, and up here it's kind of like a slush, and then it turns to rain down here. And that's represented graphically as well. So you can see those down on the bottom of the legend. They go through forecasted thunderstorms, which, as you can see, we're not going to get any thunderstorms, but forecasted down here, and it's measured in kind of like a coverage or a percentage. So that's percent of the area that would be covered by thunderstorms or predicted to be covered by thunderstorms. So that can be nice, but in the winter we don't really get any. You can also get forecasted winds. So this is kind of nice forecast tool if you don't want to look at a wind chart, which can be harder to read. So here you can see all the stations where winds are reported. So you can get surface winds. You know, and if you click on a station, you know, it'll tell you the direction, speed, and you can go all the way out in the forecast period. And you can also go up to different heights. So if your flight level, or if you were going to be flying in, let's say you were going to go up to flight level 180, you want to take a look at the winds up there. Boom, you can look at the winds up there, direction 252 degrees at 62 knots. You can go all the way up to the forecasted flight level 480. So 48,000 feet. So that's a nice tool that you can use to get the winds forecasted. And again, you can go out to any time range for that and get the winds. So you can also get the potential turbulence. It's kind of the same thing. You get different levels you can fly at, and you can go out in the forecast period. So, and icing. So right now, the icing potential at the surface, there isn't really a ton, but there, as you go higher, you can see that the potential for icing goes up a little bit, and different layers have different levels based on like cloud coverage and you know, the density of different types of clouds and whether they contain water or whatever. There's a lot of factors that go into icing potential, but the one thing that has to be certain is there has to be visible moisture in order for icing to form. So if there's no visible moisture at any of these flight levels, then there's no real risk of icing. Looks like right now the best chance up here is about 6,000 feet. And again, you can go out for any time slot during this period. So they also give you current weather. That's what these ops warn are. This is kind of like current. So you can get METARs, you can get precipitation, all this data. So PIREPs, kind of like the stuff we talked about last time. Radar, satellite, you can kind of get these all overlaid, and you can choose what you see and what you don't. You can also go backwards in the past to see what weather was like, or it'll just put it on kind of a loop for you. So that's the forecast product, the area forecast product. It's very helpful, has a lot of tools in it, kind of piles everything together and makes it really easy to get a lot of information really quickly. Any questions on that before I move on to weather advisories? Cool. All right. So we're going to go through the weather advisories. So these types of weather advisories, there's going to be 3 different types of weather advisories. These are a lot like kinds that the National Weather Service puts out, but like these are for airplanes. So they're different. So the 3 types of weather advisories are going to be AIRMETS, SIGMETS, and convective SIGMETS. AIRMETS, we're going to talk about first. They're issued every 6 hours, if there are any AIRMETS to be issued. They're issued for things like moderate icing, moderate turbulence, surface winds greater than 30 knots, ceilings that are less than 1,000 feet, or visibility less than 3 miles. If we lived in the mountains, they would be issued for mountain obscuration as well. These are called in the Weather Center, they're called AIRMETS. This is just a graphical overlay, but they're the same thing, AIRMETS. They're issued for smaller airplanes mostly. So these are not things that would typically affect larger aircraft like airliners. They're generally of like a less severe nature than their counterpart SIGMETs. There's a few different types of AIRMETS. There's a Sierra AIRMET, which is an IFR or mountain obscuration. Let's see if we can find. Doesn't look like there's any out there right now. But if there was, there'd be like this purple or pink color. Those would be a Sierra AIRMET. A Tango AIRMET is issued for turbulence. So T for turbulence, I guess you could think. Also for strong winds or low level wind shear. Currently, it looks like there are a few Tango AIRMETs issued, which are over kind of on the western United States there. It looks like they're for moderate turbulence from the surface to 18,000 feet. So those are some Tango AIRMETs. Oh, there we go. There were some. They were just a little bit lower. There are also some Sierra AIRMETs. So let's see. We have a Sierra AIRMET over here. Did mountain obscuration. And over here and over there. I'll bring this back up. So the last kind of AIRMET is a Zulu AIRMET, which is for icing. As we can see, there is a Zulu AIRMET out from surface to 12,000 feet for moderate icing. Looks like it's just to the south of us. And again, these AIRMETs are issued for smaller aircraft. These are not meant for larger aircraft. In this page, this graphical AIRMET page, you can see all the ones that are issued, and you can look at different levels because different levels might have different types. As you get closer to the ground, you'll probably get more like Sierra AIRMETs for IFR conditions or obscurations. And as you go higher, you'll probably get more turbulence or icing AIRMETs based on the weather conditions. As we can see, there's some turbulence high up here. But it's unlikely small aircraft would probably be flying at 30,000 feet. So, but they're there. So AIRMETs are something you should always check before you go flying because most likely you'll be flying in a small airplane. So you should always check and see what AIRMETs are out there. The next type is going to be a SIGMET. Now, SIGMETs are for all aircraft because they pose hazards to everybody. Generally, there's 2 different kinds of SIGMETs. There's a regular SIGMET and a convective SIGMET. SIGMETs that are non-convective are issued for like any weather that is not associated with thunderstorms that's severe in nature. So icing, that's not related to thunderstorms. Severe extreme turbulence, that's not associated to thunderstorms, like clear air turbulence. Dust storms, sandstorms, that might lower the visibility down to less than 3 miles, or volcanic ash. Just to list a few examples of what might issue a SIGMET or require an issuance of a SIGMET. SIGMETS are valid for only 4 hours, unless they're in regards to a hurricane, in which case they're valid for 6 hours. SIGMETS will be reissued if there's still things going on after that 4 hours, but they're only valid for 4 hours. So let's take a look at some SIGMETS. So we didn't want international SIGMETS. We want US SIG. So here we go. Take a look at some SIGMETS out here. Looks like most of these are for convective. Those are all AIRMETS. So there doesn't look to be any non-convective SIGMETS currently. So I cannot show you an example, but they do exist. There's just not any out right now. But like I said, regular SIGMETS are issued for anything that's non-convective. However, a lot of times there are convective things associated with it, so oftentimes it'll be a convective SIGMET more than you'll see a regular SIGMET. So convective SIGMETs are issued for severe weather that's associated with thunderstorms, so or any convective activity. So like surface winds that are greater than 50 knots, hail that's greater than 3/4 of an inch, tornadoes, anything that a thunderstorm might produce. They're also issued for like squall lines or embedded thunderstorms. Anything that's associated with a thunderstorm. So one thing to note is that convective SIGMETs are only issued for the contiguous United States. So Alaska and Hawaii do not get these. They're always issued at 55 minutes past the hour. And sometimes there are exceptions to that, which case like a special SIGMET might be issued during that time period if it needs to be updated. They're only valid for 3 hours, so 1 hour less than a regular SIGMET. And if there's no weather of convective nature, they're still issued to say that there's no significant weather to report. So let's take a look at what one looks like. So we have a convective SIGMET here. What does it say? Let's see. So this gives you some information. However, this is kind of hard to read about like the location and stuff. So sometimes it's easier to look at these on a graphical display. You can read these and decode these. However, I'm not necessarily going to go over in depth how to do that. But just for, some information, there is some like GPS kind of coordinate information, not GPS, but just coordinates in relation to like nearby airports and stuff. It gives you a little bit of information about the thunderstorm, where it's moving, tops and stuff, some outlook about it. But for the most part, it's easier to look at a map. So let's look at a map of what the SIGMET looks like. So there's a few out currently. I think this might have been the one we were looking at. So it gives you the name of the center, so KKCI. Gives you the time that it's valid, and it gives you a little bit more information about what it's for, where it's moving, how fast it's moving, that kind of stuff. So there's a few other convective SIGMETs out, but they're mostly in relation to around thunderstorms. So just to review the different types of significant weather, AIRMETS are issued for not really, that significant of hazards, but hazardous to small aircraft. They're only valid for, or they're issued every 6 hours. And there's 3 different types. There's Sierra for IFR, Tango for turbulence, and Zulu for icing. There's SIGMETS, which are issued for all aircraft. They're for specifically things not related to thunderstorms. They're valid for 4 hours, unless it's about like a hurricane or something. That's 6 hours. And then there's convective SIGMETS, which are for convective activity, that is thunderstorms, and those are issued for specifically like surface wind greater than 50 knots, hail that's 3/4 inch or greater, or tornadoes. Also embedded thunderstorms are included in that list, or squall lines. And convective SIGMETS are always issued at 55 minutes past the hour, and they're valid for 3 hours. So that's kind of covers weather advisories. Any questions about those? All right. So now we're going to take a look at winds aloft. So winds aloft, we kind of touched on earlier when we went to area forecasts. But now we're going to look at the actual like product data that they put out for us. That's not as fun to look at, but we'll still look at it anyway. So when you're looking at a winds and temperature forecast aloft, normally you're looking at this to plan a flight route that gives you optimal winds. So you wouldn't choose a route that necessarily had a ton of headwind, because headwind is bad, but sometimes you can't avoid it. So these are useful for picking good routes and good flight levels that give you the best economics. So here's what an area forecast, a wind forecast looks like. They're issued for a large area. The table here is going to give you the height at which the forecast is valid for. It's also going to give you the nearest airport or center that the forecast is valid for. So in our case, if we wanted to figure out what the winds were going to be up here, we'd have to go to the nearest station, which is Marquette. And we'd have to look at the winds for Marquette. And this is what we would use for that forecast in our flight planning. So it starts off at 3,000 feet, and then it'll go up incrementally. Now, how you read one of these is kind of complicated, but once you get it, it's pretty easy. So let's take, for instance, 6,000 feet here. So the first part is going to be your wind direction. So the wind is going to be coming from 230, and then it's going to give you wind speed. So looks like at 23, or the wind is going to be coming from 230 at only 8 knots. So pretty light winds up at 6,000 feet. And then the next part here is going to be the temperature. So on this wind, it also gives you the temperature at the certain levels. So in this case, it looks like at 6,000 feet, the temperature is -11, and that's in Celsius. So if we looked at a different one, let's say 30,000 feet, we go down and we find Marquette, and then we go over, we can see that the whole little code there looks a little bit different. Now, the reason it looks different is because they dropped the negative sign out of the temperature, and the negative sign is implied. The negative sign, in fact, is implied for everything above flight level 240. So it's just assumed that it's always going to be less than 0. So in this case, the temperature is -49 Celsius, and you just have to imply that that temperature negation sign. But reading the winds and the wind speeds is still the same. So winds are going to be 250. In this case, they're at 78 knots. So quite a brisk wind there. So yeah, that's winds aloft. Let's take a look now at some weather charts. So there's a few different types of weather charts. We're going to first look at a surface chart. Now, these surface charts are made every 3 hours, and they cover just the contiguous United States. So you don't see Hawaii or Alaska on here. And these are great for just getting a nice overview of where the fronts are, what kinds of fronts there are, the pressures, where the troughs are, ridges are, that kind of thing. So on these maps, we've kind of talked about these before, but the pressure is indicated by this gray line. And the gray lines are isobars, and those are lines of equal pressure, and the pressure along that line is indicated somewhere near it. So like this line over here is 1028. Now these pressures on this map are all millibars, so if you want to get in inches of mercury, you'd have to convert it, but it's just the way it is. And so you can follow these contours and you can get where the pressure is. One kind of rule of thumb that kind of applies some of the time is that when these lines are closer together, usually it means that there's a higher wind speed. Sometimes that's true, sometimes it's not. But it kind of stems from the fact that if they're closer together, that means that there's a lot higher gradient of airflow. So there's a lot shorter distance between high and the lower pressure. So a lot more flow over that boundary. So for instance, we can look at some of these fronts. So right here we have a stationary front, and this kind of goes along the entire United States. I don't see any occluded fronts or really any warm fronts, but the fronts will be put on this map as well. So that's nice for kind of getting an idea of what the weather might be in the future, like if there's a cold front approaching or a warm front approaching or an occluded front or whatever. You can get a good idea of what the weather might be like at a certain location based on that. Also, high and low pressure areas are indicated on here, so you can get an idea of what generic weather might be. So high pressure, like we've talked about before, is indicative of better weather. Usually means more clean air. Air is flowing outwards towards low pressure from a high pressure. So usually it's better weather, and right now we're inside of a high pressure. That's going to be passing here probably next day or so. You can also see low pressure, and you can also see troughs, which are indicated by these segmented orange lines. And troughs, I don't remember if we really talked about this, but troughs are just areas of extended low pressure. And you can kind of see that where these little troughs extend out, the isobars also form around it. So down here, you can see legend for this map too, in case you forget what any of these symbols mean. But this is a surface analysis chart that's put out. And these are great just for getting a generic overview of everything that's happening, where the fronts are, and it's just, a nice tool. I look at these pretty much every day, so they're very useful. We'll also take a look at some low and mid and high range prognostic charts. These are actually called significant weather charts. These are put out, and these are just kind of like a general forecast for significant weather. That's what it is. So there's two panels here. The one on the left and the one on the right are 12 hours apart. So this first one is a 12-hour forecast, and the one on the right is a 24-hour forecast. And so if we take a look at these, we can see that they're depicting a few different things. One is they indicate ceiling. So anywhere where a ceiling is less than 1,000 feet and or visibility is less than 3 miles, which according to our IFR definition, that's what that is. So anywhere that you see is red, inside of that is going to be IFR. So as a VFR pilot, you want to avoid those areas. You can see these blue kind of like cloud-shaped lines. Anywhere you see that, that's going to be marginal VFR because the ceiling's 1,000 to 3,000 feet, and visibility is 3 to 5 statute miles. So anywhere you see the blue is going to be marginal VFR, and you could fly into that. However, if you get too close to the red, it will deteriorate very quickly, and you don't want to get stuck. The other thing it indicates is going to be turbulence and freezing level. So turbulence is indicated by these kind of like segmented orange lines, and freezing level is indicated by a dashed and these kind of like jagged lines. So a dashed line means that freezing level is above mean sea level. And if the freezing level is jagged, that means that it's at the surface. So as you can see here, for us in particular, the freezing level is currently at mean sea level, not at the surface yet. However, it's very close. So over the next few days, it'll probably get closer and closer until we're inside that. But for now, the freezing level is at mean sea level. So that is the low. These low-level charts also are good from the surface to flight level 240. So it goes up quite a ways. They don't just include what you might think of as low. They're also issued for 4 different time periods during the day, which you can look at up here. So you have 4 different time periods that these are valid for. And if we take a look at like the 18 Zulu chart, so you can see here, this is the 18 Zulu chart for 19th of October, and the 12 Zulu chart. So there's 4 different forecasts put out on their valid at those different times. The 12 and 24-hour charts are made together, and they're just for different forecast periods. There also are 36 and 48-hour charts, however, those are not on this page. There are also mid-level charts. These are not very helpful because these cover stuff that's not really important to us because they're over oceans. But you can kind of get a good idea of where jet streams are and thunderstorms and hurricanes, that kind of stuff. Then there's high-level charts. So the high-level chart goes from flight level 250 to flight level 360, or flight level 630, 63,000 feet. So these are very high up, where jets stuff will be flying. They give you kind of a depiction of like where the jet streams are. So this can be very helpful for predicting future weather as well. If you know where the jet streams are, you can kind of predict maybe where air currents might be or where there might be air filtering down from like Canada or the Gulf or stuff like that. These charts also show you where there's hurricanes, tops of thunderstorms, even volcanoes. So anything that might cause some sort of obscuration at a high level is going to be on this chart. For instance, these thunderstorms all give you a height associated with the top of it. So if we take a look over here, we can see that this has isolated embedded CB, which CB just stands for cumulonimbus clouds. It gives you the top. So these tops out at 43,000 feet, which is quite high. And it's good to know where these tops are so that you can plan to either go around them or if you can go over them, whatever that might be. Similarly, jet streams give you height they're associated with, and you can get wind speed from them as well. So those might not be as useful, but that is a product that exists. So those are the different types of weather charts. Now I think we have covered most everything on this site that at least is important. Does anybody have any questions over anything on this site at all, or anything we've covered so far, forecasts or otherwise? If not, then I'm going to show you a few things that are maybe not necessarily stuff that you need to know, but it's good information. So these are kind of things that I've used to predict forecasts and I found helpful. You probably won't get tested on these things, but I just like to use them, so I'll show them to you. So the first thing is what's called the aviation forecast discussion. Now, this is put out by the National Weather Service in that area. So in our case, it's put out by Marquette. And as you can see, all the different stations around the country. So you can click on a station and you can get the aviation forecast discussion for that area. Now what this is the forecasters, whenever they make the forecast for that area, also put together a little excerpt as to why they've made the forecast the way they did. So in the case of the aviation forecast discussion, these are the guys that are making the TAFs and the METARs, and they're explaining why they left some things in, why there might be some things that aren't in there, but they might be become some sort of a problem in the future. So for instance, today they put out this, basically is just saying, VFR conditions are going to be predominant, might be some lake effect clouds, which lake effect isn't something that you see in the forecast. So this is kind of helpful to read this and see, oh, they're predicting lake effect, but they don't put it in the forecast necessarily. Winds will be light as the high pressure moves over us today, and it'll leave tomorrow. You see lake effect snow showers today into early evening. But then they give you a little excerpt here about why they maybe didn't put something in, or why they decided to do something. And so these are very helpful for just kind of getting a generic sense of why the forecast is the way it is, what things might pop up that aren't in there, but are still potential to be out there. So they're very helpful to read. The other tool that's similar to the aviation forecast discussion is what's called the generic forecast discussion, or the area forecast discussion. This is a longer version of what's put out by the aviation guys over at NWS. And this forecast is just more for like a generic forecast model for like everybody. It's not just generic to aviation. And so you can read through this, and this will give you a good idea of why the forecasters put in certain things into the forecast. As you can see, it's quite long, and it's updated multiple times a day as they change the forecast and as they see new things pop up. And it gives you a good insight into why they think things are going to happen the way they are. And it's usually much more accurate than even the forecast data they put out. So it's definitely for a good read, because sometimes they put little anecdotal notes in here about the forecast and why they think it might be one way or the other. So, and this as well, you can find by just searching like area forecast discussion Marquette, and it'll pop up for our region. The other thing that I kind of also like, now these are kind of hit and miss, but this is good for like if you like interpreting raw data. These are the actual models that are sent out by the NWS and are used to predict the weather patterns. So as you can see here, you get all the forecast models that you can get from this page. There are other ones, but these are just the ones that are on this page. So for instance, if we want to get the GFS forecast model, we have to select a forecast area, which is either going to be usually North America or sometimes US Northeast, but the GFS, at least this GFS model, is not put out for the US Northeast. So let's take a look at North America. Then you can get all kinds of different data from these forecast models. This is raw data that the forecast model puts out. And it's like, oh, we think this is going to happen based on this algorithm or whatever. So like if we wanted to take a look at snow depth change over some time period, we can come down here and we can loop through all the 16 days of forecast that is put out by the GFS. So it'll start us on this kind of little rocker here, and we can kind of go through and we can see how snow depth is going to change over this forecast period. As we can see, by Sunday, it looks like system's moving through just off to our north, and then it looks like everything quiets down after that. So these are very nice. You can kind of see different things. You can rock them back and forth. You can get the images. Not that you need to know this, but I just find it helpful sometimes to look at this data that the NWS guys pull from to try and figure out what's going to happen. Some of these get closer. So like the NAM high res is a much closer view. It gives us the US Northeast view instead of the full thing, but it's limited to only 3 days. So we take a look at the snow depth change over 3 days. And this is a different forecast model from the GFS. So it'll give us a different idea of what it thinks is going to happen. And generally, if we see a lot of the forecast models aligning to the same idea, then we have pretty high confidence that that outcome is going to be a reality. And so that's normally when things get put into the forecast as truth, but doesn't always happen because weather's hard to predict. So those are just kind of anecdotes I wanted to throw on there as some extra things that I use. Not probably going to be tested on those at all. I highly doubt it, but in fact, you probably won't. But the rest of it you will. So all these charts and what they mean and how to read METARs and TAFs and SIGMETS and AIRMETS and all that, you will be tested on that, almost guarantee it. So it's good to know all that stuff. So this kind of sums up our entire weather chapter. We've pretty much covered everything that we would need to know. Is there any questions at all on weather in general? Because the next topic we will move on from weather and will not return. So now's a good time to ask.
What was the TAF acronym?
Oh, so it stands for Terminal Area Forecast.
Okay.
Yeah. Basically, it just means it's near an airport. There is an actual definition for what a terminal area is. I think it's like 5 miles from an airport or something. I can't remember exactly, but
Is there any time where you'd want to look at a TAF as opposed to info from like a METAR or?
yeah. So like a TAF is going to give you information about the future weather, whereas a METAR is only going to give you information about the right now, like what it's actually recording from or reporting from the station. So a TAF is the future, a METAR is the now, if you want to think about it that way.
Okay. Yeah, that helps. Thank you.
Yep. Yeah, for sure. And that's one thing to keep in mind, that these are very similar, but the TAF is for the future and the METAR is for the now. So yeah, good stuff. Any other questions?
Where do you anticipate us moving to once this weather's coming to a close?
Yeah, so once we finish with weather, which I mean should be today, we've covered pretty much everything. I think we're gonna go into regulations maybe. I the only other section, the only other big section that we have to cover is flight planning, and I'm not quite sure how I'm going to do that yet. So I think we're going to probably go into regulations, which regulations aren't that fun, but they get hit a lot on testing, so we have to go through them. I mean, I can give you a quick sneak peek at what those look like, but they're not fun.
Yeah, I don't really usually think of fun when I hear the word regulations.
Yeah, no. So like, yeah, let's see here. I think I can share my screen. So this is what you get to look forward to. So basically, we're going to go through all the different regulations that you need to know and talk about what they are and what they mean. And yeah, like for instance, let's see if we can find a good, easy one. So yeah, like this one, 91.3. This is like basic regulations as a pilot. So like the FARs, which we'll talk about when we get there, but FAR 91.3 specifically says that the pilot in command has the final authority of the aircraft. And as such, if there's any in-flight emergency, the pilot can deviate from any instruction that's given to them to the extent required to meet that emergency. And if you deviate from the rule, basically, it says that you might have to submit a written report. But this is like one of the most common regulations out there. It's cited a lot. So it's like the basic of everything. But there's a lot more. There's a lot of slides here, but we'll get to that eventually, probably next week. So don't worry about it yet. Any other questions?